Today we're gonna, this session we're gonna be a little bit more technical. I know I'm the last session before lunch, so we will put some more technical flavor in the sessions this morning. So I'm here to talk about pragmatic container security, and just want to have a raise of hands. Who's using containers here, or who's ever used containers here? All right, we got some folks using containers. So we'll be going in depth on how you can protect your container environments in AWS if you're using Fargate, if you're using ECS, or you're just using the old school Docker engine. So why do people like containers? Um, Before we start on anything, why do people like containers? You know, the notion from a developer saying that it worked on my machine and it doesn't work on premise, right? I was a developer before, and this is one of the things that happened to me in my old job. So it's very hard to deploy an application when with all of these dependencies. Remember before when people write their applications, they tell their um, operations team and their infrastructure team, I need you to have these libraries and all this and all that, right? Sometimes there's some issues because some incompatibility or it doesn't match. But you know, containers came in, right, and packages the apps. So it's very portable. So when whatever runs on premise also runs in production. So this is how it works, right? So in your local machine, your container runs like this. You go on premises, container runs like this, and if you go to cloud, it runs the same way. So there's no more second guessing whether my container will work or not, right? Um, at the end of the day, right, containers accelerate the developer experience. We're talking about migrations a while ago. This is the best case, or this is the best type of applications or workloads to move to the cloud because it's already working, and if you move to the cloud, it will probably work the same, right? From Docker, what they say is containers provide the ability to package and run an application in a loosely isolated environment. Loosely isolated. Now, when you tell this to the security guys, your security teams, the CIO or the CISOs, they're gonna have this problem. Isolated. Um, maybe, maybe not. There is an exploit that just came out a few months back talking about the ability of a container to run root commands on its host, on the host machine. So imagine a rogue container running on your environment that's able to talk to your host, to your Docker host, right? So I know ECS and Fargate has released a patch to avoid this, but these things can happen. Now, before we go deep dive into the demos, what is cybersecurity really all about? Remember, like when you're going to AWS, when you're deploying your applications, and when you're using the cool stuff, you always have the security people asking you, you know, it's not secure. Please be careful. We don't know how to secure this thing. You know, it's a new world, not just for the developers, but for the security teams. So, what's the goal of cybersecurity, right? The goal of cybersecurity is make sure that systems work as intended and only as intended. Meaning, when you put something there, it should work the way you design it and the way you want it to work, right? So this is where your application suddenly or your container suddenly working the wrong way and leaking data. That's not how you want it to work, right? So what are we gonna talking about? What are gonna be talking about in the next 25 minutes is I'm gonna show you a containerized environment. I'm gonna show you some tactics on how to secure them, right? So what are the specific areas we're gonna look at? Number one is securing the host, right, and securing the container, and the third one is securing the pipeline. All right. So before we do the demos, I'm gonna show you the environment that we're gonna be talking about today. So we're gonna RDP on my laptop later. So we have our applications. So we're gonna be talking about two applications, right? Number one is the landing page. So think about your company. Everybody does a landing page, a product announcement, coming soon page, and then we have a file uploader. So a contest. Let's upload a file, upload your pictures, or upload your songs in this website. And it's running on ECS. So it's running on an ECS instance, and it uses AWS APIs to send data to DynamoDB, S3, and SQS. And it's using a load balancer. So there's two ports, 8081 and 8082. It's being served from a load balancer to give port 443 to the user, right? So there's also a developer environment where the developers are using Jenkins, the developers are using code commit, and there's using ECR. So it's a full-fledged AWS environment. Now, we're going to talk about how containers can be exploited, right? So before we do the demos, we just want to let you know that the, the following stunts are performed by professionals, and please do not try this at home if you don't want to get in trouble with your security teams. All right, let's go to the demo. All right. Okay, so I'm going to show you my two websites first, or two applications. Number one is called the Bryce Idle. This is our file uploader website. It's running on port 8082, and allows people to submit their files to the website. So if you know you need to submit a file, you need to upload it to S3, so you need S3 access, right? Another page is called the Bryce announcement. So it's an announcement page, and it's running on another container. All of this is running on on one instance that's running Docker inside, right? So if you look at the URL, it's running minikube.bryceinternal.com, port 8081, right? So over here, I have an exploit file. It's a Python script. So what it does is it's going to allow the bad guys to run exploits on that machine, on struts. So I have a text file here called stuff.txt where I pre-coded all the commands so I don't have to type and bore you guys. So the first attack that we're gonna run is we're just gonna run a shell command, right? So if you look closely at the blue section, it says ls-l. So what I'm gonna do is from the URL, I'm going to do a listing of the directory. So it says, let's execute ls-l. So basically, via the URL or via the command, the URL string, you're able to run an ls-l on that container. So if you don't believe me, let's run another command. Who am I? So if you're using Linux, you know what who am I does. Right. So it's just, what this script does is it will build a URL request, and it's gonna send it from the HTTP. Oh, cool! I am root. Next thing I'm gonna do, I'm gonna check cat etc. Oops. I'm looking at the password file. So now, I was able to run these commands without actually doing an SSH on that machine, right? So, let's go back to the slides again. So your bad guy was able to go in. Now what can he do with this thing, right? And maybe it's inside a container, right? Nothing wrong, nothing's gonna happen. Probably nothing's gonna happen, right? What else can you do? Number one, you can check the environment for other assets. You can do a port scan, right? Your container environment, and these containers, they also talk to other services like DynamoDB, or they talk to databases and other things. So you can actually look at network activity and see what other stuff are there. Second one, look at credentials. Does the user or the application or the container have any credentials on the database, right? Plant a callback and control to the container. So putting a callback and control allows the bad guy to run more stuff in the background without you knowing, right? Last one is use it as a launching pad to exploit other vulnerable applications. That sounds interesting, right? Your applications is connecting to this container. Maybe we can run other stuff on that. The last one is you can make it an exfiltration point. Connect to a data dump server. So there's a lot of things that you can do as soon as you were able to run as root, right? So we're going to do just exactly that. Let's go back to the demo. So we're back here on my screen. So what I'm going to do is I'm going to download this I'm gonna run a command again, like a while ago. I'm gonna download the script. So what does this script does? I'm gonna show you what it does. So I'm gonna show you what this exact script does to the server. All right. So I'm just gonna focus on these two lines of code here. So the first one is the first the first line of code says, let's find the IP address of this Docker host, right? And then number two, let's run a shell shock command on the port 8082. Remember a while ago we have two applications, right? Port 8081 and port 8082. So the second thing it's gonna do is it's gonna run another attack on another machine. So it says here, I'm gonna cat the config file from another container. So let's run this exploit. So we got gold, right? So this is what people don't want to leak, right? If you're applying best practices in AWS, you're always being told never extract access key, never show secret key um, to anybody, right? If you upload access keys on GitHub, they will actually let you know why are you putting access keys on GitHub, right? So I was able to extract access keys, so I can do pretty much anything I want. So let's go back to the slides. So what did just happen there? So now the exploit has happened. The investigation is here, right? So we all know that our landing page and our file uploader are both vulnerable containers. Okay, and the bad guy or the hacker was able to go in the landing page using a struts command, the first attack that we did, right? And because he's done a lot of reconnaissance, he found out there's another application or there are other stuff in there, he's able to use that container to launch an attack to another container, which is our file uploader. A while ago, I told you that DynamoDB, S3, and SQS is needed by the file uploader. The credentials to use to access that is actually hard-coded in that container, which you don't want to do as well. You should be using something like environment variables. You should be using something like IAM roles to facilitate a communication with AWS APIs, right? So, and another thing is, right, because you have a vulnerable containers, it comes from vulnerable images. And this is where you're going to be afraid, like, how did this come from? How did this happen, right? And because of that, the bad guy were able to retrieve access keys. So if you get access keys out, it's not a good thing, right? So let's start securing the environment, right? So let's secure the host. Let's do a demo. Let's go back to our demos. So I'm gonna run the same command, but on another instance that has protection inside. Let's see if we can find the exploit.sh. It got an error. It says an existing connection is forcibly closed by a remote host. Let's see. And then your security team will check Security Hub, right? So the first thing you want to investigate is, as an investigator, what kind of blocks or preventions has happened. So I'm going to show you the Security Hub console. So in this one, I just, like cooking shows, right? I'll show you that it's baked already. The cake is baked already. In this console, right? If you haven't heard, the Security Hub is a new AWS feature that will allow you to consolidate security events and alerts across all your environment, whether it's guard duty, inspector, and third-party tools such as our technology. So in this console, our product, Deep Security, was able to prevent that attack of struts. So if you still follow, right, the struts vulnerability or the struts attack is what started the entire chain. So if you can prevent it from the beginning, you're not going to be able to infiltrate to the other containers. So this allows you to protect your entire host. And if any attack happens from the container A to container B, it will also be detected by technologies like IPS. All right. So yeah, that's how we prevented this. So let's go back to the slides, please. So this is how the production security of production happens there. So bad guy exploits the struts. It's being prevented, right, on the host network. So from the outside to the inside of the host machine, there's prevention that happened. Now, even if the landing page, right, was able to go and attack the vulnerable file, there's also security because the Docker networking is also protected. Remember, it's not just the host, but also the Docker network. The next one is the data that we just saw, the attack telemetry that we just saw, as being sent to Security Hub. So if you want to look at the security posture or the security events of your infrastructure, you can actually use Security Hub to do that. So you don't have to look at different consoles or you don't have to look at different tools to see what's happening. And again, security of container, right? Application vulnerabilities, right? You're gonna look at application vulnerabilities. You look at patching, you look at malware, and you look at inter-container traffic. And securing the host. Another thing that you want to secure in the house is your Docker runtime and your host OS. So even the host OS must be protected, not just the containers. So now I'm gonna give you some tips on how to secure your container environment regardless of what you use. Right? So EC2, areas of focus, patch regularly. Always make sure you patch regularly. If you're using ECS, it will actually tell you that you have to patch your Docker, your ECS instances. It's not just patch your container, but also patch the EC2 instances running it. Restrict IAM roles. If you're using all these container containerization layers, you need to make sure that people won't be able to launch containers and stop and attack into it. Another one is put some controls, right? When you're running EC2, put some controls like integrity monitoring, anti-malware, just to be safe. Not just the inside the container, but the outside. Another one is ECS, right? ECS AMIs is just same as any EC2. As long as it's using the AMI specification, you're fine. Use one of the AWS provided AMIs as a starting point. If you go to the AMI's page, you just type ECS, you're gonna find the best suited ECS host, right? Now you're using Fargate, right? What if you use Fargate? There's no servers at all. How do you make sure that you secure that? It's all about IAM policies and roles. Make sure that the IAM policies and roles are well defined. So not anyone can stop and start containers that you do not want to do, right? Because it runs on AWS infrastructure, so no EC2 instances are required. Our next topic is the secure the pipeline. So I haven't seen anybody who's on a Dockerized environment that doesn't use some way, shape, or form of a pipeline, a CI/CD, Jenkins, Bamboo, code commit, and code deploy. If you're going to run containers, because of the velocity of development of applications, you have to use a pipeline. So we're going to talk about that, right? So automation is the key to being able to deliver quickly and consistently. Why don't you use that to also deliver security, right? Not just consistency in your application, but security of your containers and your environment. Right. Containers can be, this is how containers can be exploited sometimes. So if I'm the developer or the builder, I'm gonna go to Docker Hub and download a Docker container that I don't know. But I need to get my application going. So I go there and download the main image, and then I'm gonna work on it in my machine, and I'm gonna put my code inside, and it works. I'm gonna put it in my corporate registry, and I'm gonna tell the infra people, hey, please run this container, right? So what if there's a vulnerability? What if there's a malware? What if there's any issues? How would you make sure that the code that you deploy or the containers you deploy in your environment doesn't have much problems inside? We're gonna show you a demo again. Right. So I'm gonna show you my my Docker build. So my build number 52, I wake up after I deploy my code the last night, it's failing the build. How does this, what happened here, right? And it's gonna tell me that under deep security smart check scan, um, it found some findings, and content findings were exceeding threshold. There's some malware found. There's something wrong with my build. So as a developer, what do I have to do? Where do I find it? I'm gonna log into the smart check console, and I'm gonna look at my scan. What happened in my container? Oh, quite small, make it bigger. All right, so what happened to my container? So it will tell you every layer you do that there is some high vulnerabilities. By you installing this file, you're putting in a private key file. You shouldn't be doing that in your containers, right? And now you run this APK, it also introduces some key files, right? Copying this folder introduces the AWS access key ID. Remember a while ago, right, when the attack we did, we were able to extract access key from that container. So in this scenario, it will tell you, hey, you're putting an access key file in your configuration or in your container, and you should not be doing that. This layer is installing a vulnerability. This old version of Apache 2 introduces this CVEs that you need to be protecting against. And the last one is, this is just for kicks. I copied a malware into the container just to show you guys. So it also tells you that you copied malware. So how do I fix this? So what I'm going to do is, if you're fixing it, you go back to your Docker file. Let me show you this. So it will tell you that, hey, these are the commands that you need to delete. So one of the commands that introduce the iCard that I just put is actually here, right? So to fix it, I need to delete it and build it again, right? And if it doesn't have any problems, it's gonna look something like this. So it's gonna say everything has been done, it passed the checks, it's been certified, and you now can safely deploy this in production. Now, all of these are automated, meaning you deploy your code, it will push it to Jenkins, it will build the image, and it will do a scan, and it will deploy it into production without any human intervention. So this is how you can consistently deploy secure applications in your production environment. All right, let's go back to the slides. So what did they just do? The builder commits the code in code commit. Jenkins picks it up, and then the image scanning was able to pick it up, so it will scan for, again, vulnerabilities, malware, and secrets. Next one is it will show the result. Depending on the result, it will tell it will give feedback to the builder if it fails or if there's any problems, and it will push and tag clean images and push it to the registry. It will say this is a clean image, it's ready to deploy for production. And then you will have a very protected container infrastructure. So a while ago, I showed you how to protect it. Now I just showed you how to make sure that you're deploying clean images, right? So certain tips that I have when you're writing your code, right? Number one, don't use any IAM roles or permissions that has full access. I know it might, sometimes when you need to get something out, you just have to give full access. It's easier to restrict and open than open and restrict. Don't put your keys on your containers, and add some scanning and sanity checks and appropriate stages. I'm not saying about just Trend Micro products, but other products you can put in. And think about security tests as part of the integration test, right? Put it as part of the QA process. You want to test your API. Why don't you test your containers for security? If you're not running your own if you're running your own pipeline, so you just apply the same rules on principles of the EC2 to those systems. So how you secure your pipeline is the same way you should be securing your EC2 environment. All right. For builders, right? For developers, builders, you need to deploy strong endpoint controls on your developer workstation. I've seen countless times people are saying that, hey, something's wrong with our servers. And the first thing I noticed that their infected laptops are FTPing to their servers and planting malware there. And again, you just educate your colleagues to do security coding best practices. There's a lot of them online. It would really help, right? Containers accelerate the developer experience, but security makes sure they stay on track. Think about security as an enabler, not just something that you have to be afraid about. Countless of times when I talk to development teams, they always say, "We're not doing this because our developers security team says so." So we're telling the security teams, don't be afraid. Tell your developers just do and be creative and help business. The security will be taken care of, and you can find a lot of tools and technology to help you. And again, for container security, last slide about this, 6 things that you have to look on, right? Number one, look at the host. Number two, management stack, ECS, Fargate, ECR, right? Number three, build pipeline. Make sure your pipeline has security controls in it. Make sure you're securing your pipeline as well, right? Number four, application foundation, the libraries you use, what kind of languages you use. Number five, your application itself. Make sure you code properly. And the last one is network. Make sure your network is properly configured. So no open ports. Now, we have a booth near the keynote area. There are some technologies you want to see if you want to see how we do this. We have experts there who can talk to you about. So our two products is Smart Check, Deep Security and Deep Security Smart Check. Both of them are available on AWS Marketplace. Before I go, please don't forget to rate our session. It will help us craft our other presentations in the future. And with that, I would like to thank you for listening. Enjoy your lunch, guys.